Hello everyone, welcome to Application Development Virtual Group webinar. My name is Sarah Huang. I'm the co-organizer of this virtual group. Join me here is Debbie Huang, our co-organizer as well. Today, Thomas Grohser will present You should use Columnstore but avoid the mistakes I made. Thomas has spent most of the past 26 plus years exploring the deeper inner workings of SQL Server and its features while working for entertainment, pharmaceutical, and financial services industries. His primary focus is to architect, plan, build and operate reliable, highly available, secure, and scalable infrastructures for SQL Server. Over the years, he has managed thousands of SQL Server instances, processing trillions of rows, taking up petabytes of storage. Thomas has been Microsoft Data Platform MVP for 9 years and has spoken regularly at conferences, SQL Saturdays, and user groups for 12 years. We really appreciate Thomas share his knowledge with us on a Saturday night. Let me first take care of some housekeeping stuff from past community, then I'll transfer screens over to Tom. So past Summit 2019 has all the 200 sessions announced, and you can join the largest technical conference for data professionals that leverage the Microsoft Data Platform. And for more information, you can visit the past Summit website. So as an application development virtual group members, you may save $150 of your conference registration fee. The code is VGDISHX2H. If you have more questions, simply email our virtual group, and then I'll get the answer for you. This year, Past Summit has this all access process. If you want to attend Summit but never had the chance, you may tell Past how attending Past Summit will make a positive impact on your career by August 29th and 23rd. And then you may get a complimentary 3-day registration and exclusive access. Past Marathon for Analytics is calling for speakers. This event will explore topics on requirements, gathering, storytelling, visualization, predictive analytics, R, Python, and things like that, topics like that. These are the upcoming virtual group webinars. This is us, and also Cloud Virtual Group has a lot of sessions, as well as professional development, visualization, DBA fundamentals, data architect, and women in IT. And over here, my apologies when I tried to insert this line because we posted this session late. I accidentally overrode Cloud has another session in here. But anyway, if you're interested, simply visit Cloud's virtual group website. You'll see all their sessions lined up. And I just want to mention, since the slide only show up in here because I inserted in here, and we have another session called Introduction to GCP, which is a Google Cloud Platform, on August 23rd. So please attend if you could. And these are more upcoming virtual group sessions. As you may know already, PASS has many virtual groups with different subjects as well as languages. And as always, you are more than welcome to join our virtual group, which is the first one, application development virtual group. And PASS membership is completely free, and you can join those virtual groups without any fees. These are upcoming single Saturdays, and you may want to take a look. And PASS has a career center. If you are looking for a new career, or if you are an employer, you can also post your openings PASS Career Center. And this is how you may connect with the PASS. And this is how you may ask questions during our session. You may either raise your hand by click this little hand sign. So either me or Debbie will unmute you so you can communicate with Tom directly, or you may type your questions in at the chat window, and then I'll read the questions out for you. All right, that's all I have. Now let me transfer screens over to Tom. Yeah, we can see your screen, Tom.
Yeah. So let's see if everybody can see this.
Yep, we can see your slides.
And you don't see the webinar tools. They are not visible because I see them on the same screen.
Yeah, you should see what's on your screen.
No, do you see on my screen the GoWebinar tools on the right side?
No, I only see your slide. That's it.
Okay, great. Then perfect. That's what we want. Good. So, hello, everybody. My name is Thomas Grohser, as said before, and today I'm gonna share my story about Columnstore and how I went from first experience to an actual nicely and beautifully working solution in several iterations. And I hope that this presentation will save you a couple of them, if not all. And when you start using Columnstore, you do it the right way from day one. So start begin. There was already a couple of introduction about me. I usually do it with this slide. So that's my name. I work for a company called Entity Data, which rents me out to other companies. And I'm with SQL Server forever. I started when 16-bit was the common operating system architecture, and I've been with SQL 24 years now. SQL MVP, wrote a couple of chapters in the last internals book, and I work a lot with Microsoft basically I see my role as it's my job to yell at them for all the stuff they do wrong, and make the product better with them. Okay, so let's dive in. Yeah, that's the 24 years. I guess this presentation includes, I think it's 3 slides from Bob Ward. I said there's no point of making my own. He made very good slides at the last PASS Summit. I asked for his permission, and of course, he said sure to use them, and they are marked by changing the screen color to green, so we know these are his work product. Good. So the goal that I had to solve was a very simple one. A company that I consult for asked me, we want to audit all activities on our fleet of SQL servers and let the developers query the results to find bad queries, unused database components, the typical stuff. You have an enterprise, it's out there for 20, 30 years, and a lot of garbage piled up in the databases over the years. Tables were abandoned, but nobody removed them. So you're having a lot of things. This company wanted to do something about it, and the idea was, since nobody knew what was used or not, let's audit everything and then make great reports on that data to figure out stuff that is not used. Sounded simple, no problem. What can go wrong? What could go wrong was that they have about 6 billion queries per day. And they wanted to audit multiple years. The system is now in its 2nd year, and we just recently crossed 3 trillion data points, which are stored in a single Columnstore table on a single medium-sized SQL server. And after all the changes that we were going to go through together in this presentation, it actually works quite well. So we're getting started. The idea was we enabled auditing on SQL Server. It's a built-in feature. Works great. You tell it, hey, I want all these columns, all these objects, write it to files. Once the file is full, start the next file. Pretty standard operation for DBAs to do that, with one difference that normally you just audit very high level interactions, like who is logging in, who is logging out, who is dropping data or something. We want to do audit every time any object in the database is touched by a query, by an insert, by DDL statement, anything else we want to know, and we want to have it in a file. Yeah? We even created a login trigger that gave us additional information, like client IPs or so that are normally not available in audit. So that little trigger just stores it in a place where audit then includes it into the audit files. And we put these audit files on a fast file share and started collecting from about 60 production servers. And that started very well. On the end of day 1, we had 5 terabytes of audit files, and that repeated pretty much every 24 hours. So this environment creates 5 terabytes of new query data. This is just the queries, not the actual data they work with, every day. So we had to figure out how to store that inside SQL Server. The timing was pretty good when we started the project. It was the early days of SQL 2016, and we had this idea of, yeah, let's use Columnstore. It's magic. Microsoft presented it. It can handle petabytes of data. So just enable it, as they showed us in the keynote, and all your problems will go away. Yeah, not really, but in the end, it worked out well. So one note while giving this presentation, I will not go through the mistakes and how we fix them in the actual chronological order how they happened. The problem is what we did over time is tweaked several areas multiple times till we got it right. So if I would stick to the chronological order, chronological order, there would be a lot of jumping back and forth. And I've done this in a different place and it confused everybody. So I decided to reorder the slides into somehow correct order, but I grouped everything together. So when we're talking about one topic, we stick with the topic and then we'll move on to the next one. That's much easier to follow. And that's what we're going to do today. Yeah, so group them by topic. By the way, I will upload the slides later on in two versions. One version, the one you're seeing right now without anything, and during the talk I will start drawing on some of the slides, and I will also hand over a version of the slides including all the drawings and remarks, unless PowerPoint crashes and forgets all of it. Then I will probably recreate them tomorrow. So let's go to the first of many not working solutions. We created clustered column store with all the same columns that are in the audit file. That's a lot. That's about 40, 50 columns. Some of them are text, dates, integers, floating point. So pretty much everything you can imagine is in that audit. In each audit line, it has the information, which client, which IP address, which statement, in which session, how long it ran, how much it actually consumed on resources, all that stuff. So great thing to start. And we did basically a very simple program for each of the files that that the audit process wrote, insert into our column store and select the data from the built-in function fn read audit file that allows us to read in these SQL Server generated audit files. Worked great in testing, but the moment we use this in production, we had a couple problems. First, the inserts were really slow. Okay, so let's see what we can do about this. We got good, but not really great compression. So everything we could read on the internet at the time said Columnstore is way better in compressing. We didn't see this. And it was really slow to query. It took forever to get any data out of it. It was just bad. And the performance and compression got even worse when we started running multiple batch jobs at the same time, because we said, okay, we can read files from one server on this thread, and then we opened the second management studio window and ran it for the second server at the same time, and that actually made it worse instead of better, because all our 25-year knowledge was, hey, if you run things in parallel and they don't collide, SQL Server usually is pretty good in speeding things up. Not in this Columnstore solution. It did just not work. So with all this, we could read about 10% of the data we needed. And that meant it's not working because practically this amount of data will charge. I apologize if you can hear sirens in the background. I live 3 blocks from a police station, and sometimes they get busy. So what happened? We basically ignored all best practices for Columnstore because we're SQL Server veterans, so why should we read documentation before doing anything? We just created the table the way we would have done any row store table, inserted the data the same way we would have done in a row store, and we got the response from SQL for it. It just didn't work. So what did we have to change? First of all, what we learned very quickly is that there's a sweet spot on how many rows of data you should insert at a time in a column store. Okay, that was interesting. So we will keep that in mind. We should avoid data types that use more than 8 bytes. Okay, that's strange, but okay, we'll have a look at that. And partition the table. So, okay, and don't rely on Columnstore to do normalization via compression. Because what we thought is, hey, the latest version of Columnstore, you can put in a varchar max and it will just compress it and put it in there for you. Just because something can do something does not always mean we should use that feature. And we, over time in this presentation, will learn why. Yes. So before moving on with Columnstore, a very quick refresher how Rowstore stores data. So in Rowstore, when you insert a row of data, SQL Server generates a row header that basically says, yep, this is a row of data, and this is some information about the columns that are in there and how they are ordered and which ones are null and all this stuff. And then it stores one column after the other in basically a byte array, yes, till it reaches the end of that column. This column then gets copied into a data page, the first row, a couple of bytes, and the next row, same thing, slightly different length, goes into the next free spot on the page, and so on. And if there's a small row, SQL Server can stick it in between. Rows are not sorted within the 8 kilobyte page. And then it continues row by row till the page is full and then starts filling the next page. So every time when we do any kind of query that, for example, we want to select column A and column C and want to do this for each row, what SQL Server has to do is read the complete page and then read the next page and read the next page with all the data. And just imagine, in our case here, it's only 4 columns, but usually fact tables or our table had like 50 columns. If we only want to approach a query with 2 of them, we have to load the other 48 every time for every row. And that's a massive impact on the storage engine and the IO that we have to load in. So this is how Rowstore deals with the data. So on the other side, Columnstore takes the same table and stores all the rows of column A, one after the other, the values, and then does the same for column B, and then does the same for column C, and so on. Yeah. And a set of these rows together is called a row group. And then the next row group, and so on. So if I now want to query column A and C, all SQL Server has to read is column A and C, and the other 48 columns would not be processed, copied into memory, anything else. So this is the thing is, how SQL does this under the covers is very simple. It takes one of these row groups, compresses it, and then stores it in a regular row store as a blob. You can actually query these blobs and look at them. It's just a bunch of binary compressed and almost looks like encrypted data, but it's not. It's just compressed. And then, so each one of these row groups, and these row groups can contain over 1 million rows at a time, are stored in one actual row in the database each. Okay, so much for the basics. Standing thing is. So what we learned is that we should insert 1,048,576 rows at a time. This looks like a very odd number unless you're a math genius, and you can immediately guess the square root of this, which is 1,024. So it's basically someone at Microsoft decided 1,024 times 1,024 is an awesome number for computers, not so much for human beings. 1,048,576 rows at a time is a good idea. Not more, not less. And this is the strange thing. Yeah? Columnstore, one row group, what we just saw on the previous page, this here is this, 1024 times 10,020 rows. Yeah. So this, I call it a mega, like a megabyte, a mega row, a mega rows. A mega of rows is what needs to be inserted in one go. With this way, you get the most optimal compression inside a column store. So every time you do an insert, SQL Server creates a new row group. That's very simplified, but that's actually almost what happens. Yeah? So if you are inserting one row at a time, it literally creates one row, compresses it, and puts it in there. If you do 10 at a time, it does 10. If you do the 1,048,000, it does this at a time. If you do 1,048,577, it creates a row group with the 1,048,576, and then a second one with one entry. Yeah. That's the size. It's just insert this number or sacrifice either compression and performance later. So what happens if you insert less rows? You either create smaller row groups, which slows down processing and reduces compression, what we already said, or if the number is really small, SQL Server is actually a little bit more clever and creates a second table that is a regular row store and stores these small amounts of rows there. And then when you query, it unions the two tables together. And just describing it makes me already crawl that SQL has to union stuff together. That you can, if you're working with SQL for a while, you know that's gonna really be bad for query performance. Yeah? So what happens if you insert more rows? I already explained it, but here one more time. It does the first 1,048,576, and yes, I will say this number a couple of more times. I apologize, but it's really important to get to it. And then it creates the next one with the remaining rows. If it's, I don't know, if you insert 10 billion rows at a time, it will create a lot of them and then one small one at the end. Yeah. If you want to insert more than this number of rows, do multiples of these numbers. So 2,990,000 something is the next number, and so on. Yeah, that's fine. So if you want to copy 10 times as much rows, that's perfect as well. But keep it a full multiple of this number. Yeah. So if not, SQL will create small groups and then insert the rows. So this is how Bob Ward explained it in the summit session. Quick reminder, if the delta row group is less, if it's less than the magic number, it will insert this into the delta row group. The moment it reaches this number, exactly this one, it will use a delta row group that is closed, and it will compress it. Okay? If you delete, it will eventually remove it. So here's the magic. If it's less than 100,024, 102,400 rows, it will create a B tree for you. It will not create an actual column store, it will create a B tree. So if you insert 100,000 rows at a time, you're actually just creating a regular table. If you insert the next 100,000, it will create more entries in that tree table, in a regular row store table. If you, at a later point in time, rebuild the index, it will actually compress it into the right amount of data, but that's a very, very intense operation and will, for that time, remove access to the table. So let's try to avoid it. If you insert more than 102,400 rows, but less than the 1,048,576, you get a compressed row group immediately, and then you get the next compressed row group, but they contain not all possible values, and therefore you get theoretically less compression, or practically you get less compression. Yeah? If you do an alter index later on, everything gets nicely reorganized into the right thing again. But same as when you move the row store into the compressed row groups, while this alter index rebuild index is happening, access to the table is pretty much not possible. When you delete rows, let me say it this way, never delete rows. Delete is even worse. What happens when you delete a row from a column store is it doesn't get removed. What actually happens is the SQL Server again creates another table that is a regular row store and puts the row in, which marks this row as, oh, it's deleted. And then it stays there till you rebuild your indexes or truncate the table. Yeah. So imagine you first insert all the rows with less than 100,000 rows at a time, which creates a row store. And then you delete half of it, which creates another row store. And then every time you have to query the whole thing, it has to join and union all these tables together to just give you the data. Performance is really bad. And this is what happened to us. We inserted as many rows as came in the files, which at sometimes were very little, at sometimes were a lot. So we randomly had row groups or row store extra rows. And since we were still in the early days of the development, we also deleted a bunch of stuff. When we accidentally processed the file twice or so, we deleted rows, and it created like a super horrible performant custom store, column store. So this is how Columnstore is. This is a little bit of background information that will help understand the changes that we made. So the very first change was that we realized that the fn-get-audit function within SQL Server is not gonna be fast enough. So we read and spoke with Microsoft and found out that the functionality of this function is actually exposed in an audit DLL that can be utilized from C#, Visual Basic, or your other favorite .NET development language. And that's what we did. So we imported that library in a project and made the file reading outside of SQL Server in a C# project. And the C# project then could do a lot of work for us outside of SQL Server, which saved a bunch of license fees because we already panicked and says we're going to need a SQL Server with lots and lots of CPUs, which luckily we don't, since we can use this DLL outside of SQL Server and do all the audit file processing before we insert the data into the database. So this gave us the newly redesigned architecture where we had agents, we called them. It's just a machine that runs a Windows service that processes these audit files, which then used bulk insert API with to bulk insert into SQL Server into an in-memory OLTP table. And then we had a process, a SQL Server agent job, that waited for the magic 1,048,576 rows to be in the in-memory table. And once it found that many rows, it took them and inserted them in a single statement into the column store. So we now created perfect sized row groups from data from the audit files and filled the state of things. The nice effect of the agent was also that we could just add more of these agents and use the same bulk API to write in parallel in the in-memory table, fill it much more quickly, have it move all over the data. The part on the right is inside SQL Server. We have whatever CPUs and memory and everything we need here. We have to license as SQL Server. The application servers that process the audit files in parallel were just regular Windows servers with much, much lower licensing cost than SQL Server. So this started to work pretty good to move the data in, and compression within Columnstore became much better, query performance became much better, but we were still not happy with the whole thing because we were still not following all the best practices. The next thing is, if you work with Columnstore, you have to partition it. The reason for that is, while Columnstore is great when it comes to compression, it's great when it comes to just reading the columns that you need. Columnstore only has one access method, and that's pretty much a table scan. So every time you ask a Columnstore for any kind of data, it basically, so if you want column A, B, and C from a table with 48 rows, it will take column A, B, and C and read the whole table to give you the result you're looking for. There is the possibility of putting indexes on top of it, but that we'll talk about it a little bit later. Didn't work well. So one way of helping it is that it's actually not performing a table scan, it's doing a table scan with partition elimination. So if you partition by a search criteria that is pretty much in every query, then you reduce the amount of data massively. So as said, only one access method for table scan, which is actually partition elimination table scan. Always partition by a common search argument. We chose date. Every time people query the data that we have, or at least 99% of the time, there is a date range involved. So they want to see what happened this week, what happened this month, what happened across the end of the quarter. But in any time out of 2 years of data, they usually limit the result set to less than a month, in I would say 90% the cases, even less than a week for the whole thing. Yeah. So partitioning by day almost worked. We have 2 years of data, so we want to keep roughly about 2 years of data. We haven't come up with a solution how to proceed with the data. After the first 2 years, we took a backup of the database and put it aside. So we probably in now starting relatively soon gonna start deleting the oldest partitions in the production database, and then have the older data on the archive server. We still don't have a solution what happens in about 2 years from now, when the last partition that's already on the archive server is to be dropped, and then we have to move the data over, because that's not so easy, but we'll get to this later. Yes. This gives us about 750 active partitions, and that's way below the magic number of about 4,000. We scoured the internet. What we could read is, if you go above 4,000 partitions, there's all kinds of funkiness that starts, because SQL Server, while officially allowing you to do like 15,000 or so, everybody that tried that somehow had issues. And so the recommendation from Microsoft and all the websites that have good information is don't use more than 4,000. We are at 750, and we're planning on staying at this number roughly. So we're pretty good, and it works pretty good. So whenever we specify in the where clause something that limits the dates to a reasonable range, only the partitions that contain a date that we want will get touched. Everything else is not even scanned or looked at. So this enabled us to have most queries that run for a single day be completed in 40 minutes, which for 6 billion rows is not that bad, but we expected more, and you will see that we can get much more out of it. So the next thing is, in our very early versions, we let Columnstore do the normalization by using extreme good compression for us, but we learned then very quickly that this is a very bad idea. So what we learned is that all data that doesn't fit in 8 bytes should be in an extra table and be referenced unless it makes no sense. What we had in the table was things like computer names, IP addresses, application names, things, yeah. All these data is actually only a few values that are repeated over and over again because people don't rename their laptops, they don't rename their workstations, applications don't change names that often. IP addresses rarely change, but these are all objects that are way more than 8 bytes. Columnstore could handle them, compress them pretty well, but when it came to querying them, it wasn't very efficient. So we started normalizing all this out, like server instance names, client workstation, the queries itself, which were really big strings, information about the sessions, information about the database objects like database name, schema name, table name, column name, all this, lots of text. So whenever we had text, we figured out, hey, best practice in a normal row stores would be to normalize all this to avoid insane amounts of data. While Columnstore prevented this amount of data by doing super high compression, we actually created a very bad data model by not doing it. So normalizing the query, first of all, we removed all literals because we figured out it doesn't matter if someone selected blah, 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 where x equals 5 or x equals 7 or x equals 10. For our developers, that's all the same. They don't care about the actual value. They care that this query was run and used certain tables or views. That was the information they were looking for, not what the actual query was. So removing all these literals made a query that looked like this, and when then the next an insert with this like would look like this. So to show you this, the actual literal got replaced by pound signs, and the same in the other values. And this allowed us, when a second query came in that just had different data, it could, the removed data, they are the same. Yeah. So instead of storing both strings, we only had to store one string. So how did this result? Over the first about 6 months, we only saw 3 million different queries. So instead of storing 6 billion strings per day, that could be easily, and these are short queries I'm showing here. Our reality, we have queries that are several 100 kilobytes long. You all know these big joins of 30 plus tables with complex join conditions and very complex where clauses. We have them a lot. So altogether, only about 3 million entries instead of 6 billion per day. That's a lot. That is a very good normalization, and we received lots of things. We're back on the blue screen. That means we're talking about the part that's outside of SQL Server. Bear quickly with me. So C# was much better removing the literals than SQL Server. Instead of doing very complex queries with T-SQL, we just let the C# component remove the numbers and strings. And then we created a hash of the query. Actually, we created 2 of them. And use the compress function to store the actual text. So gigabytes of text data became several megabytes. And as I said, 3 million unique queries out of about 2 trillion entries. The thing is, we get a couple of hundred news every day. This is pretty much the usual software development. Things get added or removed, or people trying ad hoc queries that they've never done before. We also, after a while, changed it and we ran the whole hash thingy and removed all white space. So if the query select space space, column name from became the same as select space column name, which also reduced the number of things. So when people just ran a query with a couple of extra empty lines in between or put a couple of spaces at the end, that became the same. And in one more go, we then removed all the remarks as well, because again, that was not what helped. Once the developers knew the query, they could easily find the remarks in their source control. And we did also try to convert everything to lowercase. That did not make much of a difference. So we created another table for the client information, which holds basically the server workstation IP address information in one table, and then gets referenced into the Columnstore. There's only a few thousand entries there and maybe a handful new ones per week. Every time we hire someone, there's a new workstation. Every time we create a new application server, there's a new entry. Other than that, this is pretty static data. Same goes for the object store. All the object names inside the databases that we have went into another table. Database schema, table view, columns, all this. Yes, there's some movement there. Every time someone adds a new column or so, there's a new entry. But after the initial population of the table, which was a couple of, I think about 30 to 40 million entries, this is also a very slow changing dimension. We get a couple of hundred new rows every day. Yes. The last one is we created also a partition dimension, which contained lots of the date information, so we could easily group weeks together, months together, and make querying easier for people, and just have a single value for the actual day and time when the operation happened in the table. Yeah. Good. So sessions and events, these are the two big items. Sessions is every time someone logs in and out. We store this in one table, and all the queries, which are the events, are stored in a second table. They're both column stores, and they get very rarely joined together. If you join two column stores, it's a very bad operation because I just saw a question from Devi. If you hash all the queries, then how do you know what queries are being ran? So the hash is just there to find them faster. When a new query comes in, we hash it again and see, is this hash already existing? If yes, we know it's already in the database. Every query that is stored in the database has an ID, and that ID is then in the Columnstore table. So if we create a Columnstore table and we actually want to know the queries, we can reference them in the other table. So it's basically we're creating a lookup table. The reason we hash them is that we find them faster. Because if you just take the query and search for that one every time you see if it's already there, it takes a long time. The hash is a 32-byte value where we have a unique index on and can very quickly find that. I hope that answered that. So back to sessions events. If you join two column stores, it's a mess. Since there's no primary keys, there's nothing that SQL Server can in any form optimize. What it basically does is it has to do a hash join. Basically reads one of them, builds the hash table, reads the other one, and sees what it can match. If you have very large partitions like we have with 6 billion rows, if you build a hash table with 6 billion entries, be prepared for your TempDB to be very, very, very large. In our case, if we need to join them, we have a volume that's 8 terabytes just for TempDB, so we can join all the sessions to one day. It's a very rare event. Normally we don't need it because the information, which workstation or which server, which is a foreign key reference into the sessions table, is enough. The sessions we only need to join if we want to know how much compute resources were used by the queries in that session, because that information is only in the session, not in the events. Good. Yeah, so events has an entry for everything. And every column in the events table is now less than 8 bytes. It's either a date or anything is. So this is how the new schema looks like. Everything revolves around the events, which is the actual queries, and they are correlated. Events contains a session ID. They both are partitioned by date. Event references an external object table. Event references the external query table, and session and event reference the client table. So there's a line missing. There's also a reference here. We added that to remove the need to join with session. So why did we went through all that painful normalization and writing lots of code that made it happen, that updates the external tables and ensures all the data is in place across multiple engines? Why did we do this? Because we wanted the magic of column stores. And now this is the part where it gets really, really nice and interesting what Columnstore can do. So the first one, when all your data is less than 8 bytes, what Columnstore can do is it can push down aggregates. So if you want to know a count star of something, count star where some other column equals a value, or if you want to sum something, so how many executions of a query happened, or if you generate an average or something like this. If the data is less than 8 bytes, SQL Server can push down the aggregate to the storage engine. That means the query processor doesn't have to actually load the data, process the data, and then hand on the result. What happens is, instead of reading a million rows, then adding them up, the storage engine just returns the sum or the count or whatever else, the average, without actually ever returning the data. So SQL Server has to process a lot less information. Yeah? So this helps a lot. So instead of moving it into memory, putting it into the engine, and then letting it do there, the storage engine just calculates the aggregate and returns the result. Same goes for filters. So if you do a where clause, instead of loading the data and then comparing each and every column and each and every row in each column that is referenced with the filter criteria, it just gets pushed down, and only the rows that match the filter are actually loaded into memory. Yeah? And this helps a lot. Just imagine you're looking for a very specific query ID that only had like 10 entries. Instead of loading all 6 billion rows and comparing it to that one value, SQL Server tells the engine, scan through the data. If you actually come across the row, please return it to me. Yeah, this is a gigantic optimization that helped out. Yeah. The next one is row group elimination. We all remember that we had these little row groups per column. Yeah. And now we have in each one of these row groups, we have lots of data, yeah, like 1, 2, 3, 4, 5. Yeah. What Microsoft does is they basically, in the metadata, store, hey, this one, smallest one is 1, largest one is 5. And then we have 6, 7, 8, 9, 10 here. So here it's 6, 10. Yep. And don't remember, there's a million rows in there. So practically it would be like 1, and the next one is 1,048,576, and so on. Yeah. So if now we have a where clause, where, this is column B, sorry, very bad writing. Where B is 7, SQL Server looks at the metadata of the first row group, says 1, 5, 7, not in there, not even looking at it, moving on to the next one. 6, 10, yeah, 7 could be in between. Filter push down. So first eliminates, doesn't even look at this. So check here. Does the filter push down? Yes, please, just give me back the row. So it will, when we select all these rows, just grab this around. And if we have a couple of hundreds of them and we want to sum, it will actually do the sum for us and then just return the value, whatever sum is. So let's say 27, yeah, of this other column here. Yeah. Yeah. So this is the magic what happens. Yeah. So just imagine column B would be like your server ID. Yeah. And you're from your application server, and you have thousands and thousands of entries of one server and then thousands and thousands of entries of the next server. And when you query a filter, SQL doesn't even have to look there. So even there are no indexes with this row group elimination, lots and lots of data doesn't even get looked at. Yeah? Push down filters, you only get back the rows that are interesting. And since we also used aggregate push downs, we literally, instead of transferring billions and billions of rows back, we literally get value 7 and the sum is 27 back. So we probably get 128 bits back, so 16 bytes instead of megabytes and megabytes returned from the storage engine. And this is where Columnstore becomes that fast. But we're not at the end, there's more. So aggregate pushdown, you have some average from a table. In a row store, it would load the whole, every row into the buffer pool, go through it, calculate the aggregate, and then discard eventually the page from the buffer pool again. In Columnstore, if you use more than 8 bytes, it just loads the column X and does the calculation for you. If you use less than 8 bytes, the storage engine just returns the result. It doesn't move the data into the buffer pool. And that is what makes it so fast. So meet your new best friends. Big int, less than 8 bytes, or exactly 8 bytes. Int, small int, tiny int, datetime, datetime 2, time, float, binary 1 to 8, character 1 to 8, ncar 1 to 4, small money, money, and date. These are the columns data types that are less or equal to 8 bytes, and you can use. Everything else, you are throwing away aggregates, push down aggregates, and push down filters, and row group elimination. Yeah? And these are the 3 top reasons to use Columnstore to get the benefit of these. Yeah? So you can have larger data types in it. I would not recommend it at all. Filter pushdown, same thing as with aggregates. If it's a simple query. If you have a filter that has 15 ors, when, if, join, other things, case, if statements in them, don't expect that to be pushed down. But if it's a simple, less equal, equal, larger, smaller than, that stuff can be pushed down. Yeah? Probably in future versions it gets more intelligent, but for now, keep it simple, then will be pushed down. If you have 16 intersected case statements, that will not be pushed down. I can pretty much guarantee that. Yeah, so So what the query engine actually has to do is it only gets back the rows that match the filter criteria and then calculate the result based on whatever the result is. Row group elimination one more time. Yeah. Imagine all the rows in a row group have a date from 2017 and we'll filter for larger than January 2018. It would just skip the whole row group as said before. So if it's less than 8 bytes, SQL keeps a min and a max value. If it's more than 8 bytes, they just don't have to store in the metadata to save the min and max value. Yeah. So, and this means we just processed over 1 million rows with a single if statement instead of scanning through that million rows, which you can imagine is much faster. How can we help row group elimination? That's something we learned over time. You remember we had that architecture where we insert into an in-memory table, and then once we have the 1,048,576 rows, we insert them into Columnstore. Yes, that was a great idea. We went even better. We looked at our main filter criteria that is in almost every query was date. The second one that is in almost every query was basically we're looking at the application ID. So what we did is we sorted the data by, we waited till we had 1,048,576 rows from the same application ID and then inserted it into the column store. So they were all together. So either we were looking into one application ID, then they were all in that row group, or if we were looking for any other, they could easily be skipped. Yeah, so that helped us a lot. Once the end of the day we reached, we took all the data and put it in so that we can close the partition. But during the day, in the beginning of the day, most of the row groups contained only one application ID, and then we also started sorting by the remaining columns in order of how often the search criteria can come in. Yeah. By default, Columnstore just inserts the data. If you at a later point in time rebuild the index, it tries to optimize a little bit, but we figured out, knowing how our queries work, we can do a better job. Yeah? They group stuff together when you do an index rebuild, but they don't remember what was the most used search criteria, so they just sort it by some random order. I guess. Yeah, so the trick is to sort the data. This is a warning. This is the current implementation. This is not guaranteed or whatever. This is what we observed right now. We're doing it right now. It helps. We fully understand that in any future version of SQL Server, and you should understand that too, this behavior can change. I just remind everybody, before SQL 7.0, all results, whenever you queried something, they were always sorted by the primary key. In 7.0, that changed drastically and broke a lot of application that upgraded because nobody ever specified the sort order. Hey, primary key, perfect. That's all what we need. Yep, the engine moved on and didn't have to sort all the data before it processed it. And the same can happen here. Yeah. So we avoid the index rebuilds because we trust that right now with the current implementation, we're doing a little bit better job than Microsoft does. And this gets us to the last and hopefully best item, batch mode. Also introduced with Columnstore is a new model called batch mode. To happen in batch mode, again, requires again to have a lot of the involved data to be less than 8 bytes or less or equal to 8 bytes. What happens is, instead of processing row by row. They process about 900 rows, and what we currently observed is 936. And thanks to Bob Ward, that sentence is no longer true, and you will see in the next slide why it is this crazy number. Not like a 1024, like by the how many rows you have to insert. No, now it's 936. So what the difference is in batch mode is, we all know this little case, how when we do an query plan, how this has all these nice little arrows, and then they go this way, and then there's another one. Yeah, the query plans that nobody really understands, but SQL Server creates a lot of them. This is without batch mode. What happens is that the first operator says, I need data. The second one says, yes, give me this data, give me this data, give me this data, give me this data. And then when this one says, there's one row, and this one says, thank you, please the next row, please the next row, please the next row, please the next row. And then it goes row by row, back and forth, till all the data is in the front and the result can come back. In batch mode, instead of doing it row by row, it says, this guy tells this guy, give me 900 rows so I can move on, and then pushes the 900 rows to the next operator, next operator, operator. So instead of going 900 times back and forth and telling me, give me one page, like, just imagine you have a coworker and he has to give you a 1,000-page document, and you have to ask him for each and every page, and then he gives you one page at a time. This is going to take a long time. If he just takes the stack of paper and hands it over to you, you both can go home at a reasonable time. Yeah. So this is batch mode. Instead of processing row by row, which made sense in a row store, it's now processing a lot of rows in one go. Not all operations can run in batch mode, but in every new service pack and every new CU, I've seen more and more things going into batch mode. They even started using batch mode in regular row store tables for certain operations. It's a good idea to process more than one row at a time. And CPUs and everything became powerful enough that you can actually do 900 operations on 900 rows in a time before you yield to the next one. So that's a nice thing. And this thing's also made the already faster queries much faster. Imagine you have what we had here. So I have my 6 billion rows, and I want to know how many queries did each application run on that day. Yeah. In RowStore, I would have to load all 6 billion rows and then aggregate it together. My case is we use pushdown for filters and aggregates to get the data, and then for each application we get the data back, and then SQL did 900 of them at a time, process them, cut to the final results, and go back. So something that took 40 minutes in the beginning, as we talked when we ran a query, after normalizing everything and enabling batch mode through the normalization, we are now down to most of the queries answering in single-digit minutes on a data set that is 6 billion rows out of 3 trillion rows, which I think is a pretty good end result of the whole project. Here's the slide from Bob Ward that explains why it's these funny number of 900 rows per page. Is you take a 64 kilobyte page of memory, block of memory, you have our 8-byte values, you take up to 4 columns, which is basically one row, and stack them into an array, in a byte array. You need a little bit of overhead. You have the 8 bytes per entry, and when you divide all that up, you end up with the 900 plus entries per batch that you can find in 64 kilobytes. So what happens is that SQL Server literally works on 64K at a time instead of one row at a time. And what they also use in batch mode that they couldn't use before in row mode is, so if you have this row here, basically, so this is 1, 2, 3, 4, and each one of them is 64 bits. in the newest versions of the CPUs that are out there and that your actual servers right now have. So for example, let's say you want to add these columns in older CPUs, you could have read the 64 bits and add them together, and then load the next 64-bit, load the next 64-bit, one at a time. Thing is, with modern CPUs, you can use these vectorized execution thingies, and you can basically tell the CPU, hey, these 256 bits, which is 4 of these values, I need them to be added up, and the CPU does it in a single instruction. Yeah? Which of course is much faster than looping through the whole time 4 times and doing it one by one. So this is the magic of why it's 9,000 rows at a time and why batch mode is even faster, not just that it's not communicating 900 times to get the data moved, it's also once the data is in process, these new vector-oriented assembly instructions allow them to process the data much faster. So this got us from about and completely unusable Columnstore that didn't even be able to load the data in about 6 iterations to a Columnstore with 3 trillion rows that can pretty much answer any query in less than 2 minutes that we have. There's certain queries that take longer, especially when we like create something that spans a whole year or so of information to see like trend lines, how do we have less queries, or how much resources these queries take up now. But the usual ones, hey, are these items used or not? These queries can be satisfied in 2 or 3 minutes, and that's a reasonable time for a developer. So they start that query, they let it run, they have a coffee or so, and they have the answer, and then can continue with their work. What we haven't solved yet is pretty much we have a lot of unknown sessions. The problem is someone logs in at 8 a.m. in the morning, we get a login event, and then uses this connection whole day and never logs out. But our audit files roll over, and if we don't process them in order, we don't have any idea that that person actually logged in or logged out, so we cannot address the actual person, the actual session to that event. We still know from which computer it's coming, so we can most of the time make a very educated guess, because usually our application servers just run one application at a time, and therefore we can pretty much accredit the query to the right application. Sometimes we can't, thing is. And the other one is the actual opposite. If we have audit files, we have a couple of servers that are pretty lazy and do pretty much nothing. While on the busiest servers, we roll over the files like every 15 seconds and have the next audit file full. We have a couple of machines where it takes like 3 or 4 days to fill a single audit file. And then this thing comes over, which of course then messes up our already closed partitions, and we have to reopen them and insert that little bit extra data. This is, unfortunately, you can't, like with the error log or so, the SQL Server has built-in functions to recycle it. For audits, that doesn't exist, because all we would have to do is tell every server at midnight and say, start a new file, please, so we can process the day. The only way to do that is either to restart SQL Server, which is a very horrible idea in our environment, or the other one is remove and add the audit, which bears the risk that we miss something. So we're not doing it, we're dealing with it. So what we're basically now doing is we're waiting till we have at least one file from each machine before we start processing a day. And then, so we're now usually 4 days behind in processing, which is just fine. Yeah, this is. So this was the presentation. I hope it wasn't too long. Yeah, if there are any questions, you can ask them now, or I will also give you my email address. Let me quickly do that. Keep the work. Yes, keep the work. And now I have to save that. Save a copy. This PC browse. Give me 1 second so we don't format. So we don't lose. So we don't lose the scribbling I created. I will give you my email address that you can use.
Yeah, Tom, if you could
Yeah.
email me this set of slides,
Yes, yes.
how would yeah,
I will email you all the slides. So and
yeah, I already posted the one you had SQL set yeah
mhm, yeah,
Saturday on our website, then
yeah.
I'll post this set as well.
So you should still see my screen. So that's my email address, tg@mylastname.com. And I usually answer on the next weekend. So clever people email me on Friday, then they have a quick answer. If you email me on Monday, it might take a while. Uh,
Yeah.
just so yeah, I will send both slides to the organizers so they can make them public. Any questions?
Yeah, we got one. It says a couple of years ago, I had to manage a fact table with a lot of columns, more than 250 columns. Is it
Mhm.
okay to have such big table with a column store?
Yes, that's what Columnstore is made for. Yeah. So Columnstore, if you have lots of columns, that's great. Most of the limits in Rowstore don't exist because a single row doesn't have to fit in an 8K page. So this is perfect, especially if you have these 250 columns or even more, and then in every query you just use a few of them. This is where column store goes in because it reads only the columns that it needs to read, not the whole row. Yeah. So yes, wide tables, the wider, the more efficient column store is. Even worst case, if you need all 250 to read every time, Columnstore will do a much better job compressing the data and therefore will speed things up. Yes, so white tables, that's what it's made for.
So do
Uh,
you need to? Okay, go ahead. Sorry.
yeah, but keep in mind, 8 bytes or less in each one of the columns. So if you have half of them are long text things, then it's not as good. But if they are nice, like lots of things, the floating point numbers, all this stuff, that is great. Dates, integers, counts, how much stuff was sold, the price information, all that. That's usually pretty good.
So do you need to drop the column store before you insert like a giant amount of data, or you don't need to?
No, no. So I didn't go into that. So what we were talking today is what is called clustered column store. The
Hmm.
clustered column store is the table. There is no table. This is not an index on top of a thing is. So the very first version of column store were just an index on an existing table. So you had to have a table which was either a heap or a clustered index, and you created a column store on top of it that could make your queries faster. What I was talking today is something is called a clustered column store, which when you create it, when you have a heap and you create a clustered index on it, the heap gets converted into the clustered index. If you
Hmm.
have either a heap or things, or you create a new clustered column store, this is the table. There's no second copy of the data. This is the only place of the data. So you don't have to insert new data. You just keep inserting new data. You don't have to empty it out.
Okay. And you mentioned in earlier that the delete record,
Yeah.
it's a mess, right?
Yes, I
So
stick with that.
so I mean, y-
Yeah. There is no
well,
actual delete. A column store cannot delete. It cannot remove a column.
mhm.
Sorry, it cannot remove a row. Yeah. So instead of deleting it, They cannot delete it, so they create a table that basically has a list of all the rows that need to be deleted. Since a column store, a clustered column store, does not have a primary key, they cannot just reference the primary key as the deleted, so they have to copy the whole row into that. This is the
new
deleted
table.
rows table,
Mm.
and then join. And if it joins, then don't show the table, don't show the row. Yeah. And that just makes it insanely slow. It immediately removes all capability of push down aggregates, push down filters, because all that stuff cannot happen because the push down code has no idea if this row exists or not. Yeah. So the moment you delete, you throw all the performance out. If you have to delete, you have to do an index rebuild afterwards. Yeah. So if for any reason something is the way we delete is we delete a whole partition a whole day at a time by dropping the partition. Um, but we would never delete an individual row out of it. It just kills everything on performance that is there.
So when you drop a petition, do you
Yeah.
need to rebuild the index?
No, nothing. We do it like you did on a row store for partitioning. We switch out the partition, and then so the partition becomes a separate table, and then we drop that table, and the remaining clustered column store stays intact as it is. There's no If you delete a whole partition, it it's a metadata operation, takes a few milliseconds, and the data is gone, and the rest of the clustered column store is perfectly fine and intact.
So is it possible to say like create a flag, a column like a flagish? Then you just mark, okay, these do not query or something, and
Okay,
you have to, yeah,
so
eliminate one row.
theoretically, yes, but let me explain how an update works. Clustered column store has no concept of an update. So what's the workaround if you can't do an update? It's an delete with an insert.
Oh boy.
Yeah, I didn't mention it in the presentation. If you do updates on a column store, yeah, that's the end of it. It literally create if you update a single row, it just the one row kills the whole thing. It creates the deleted table entry and then creates a second table with the new row. And then everything has to be union, merged, joined every time you query it. All optimizations are out of the window. Yep. So delete is not the
Okay.
worst you can do. The really worst is an update. So neither update nor delete should be in any column store. If you need that a lot, um, consider not using a column store. If you this is for large fact tables in a data warehouse kind of scenario where you have all your data, it's the way it's supposed to be. You move it in, and then you query it for the rest of your life, but you never change it. And most data warehouses look like this. If the data is still in flux, like while the month is not closed yet, and you might have like canceled orders or something like this, then keep the last month in a separate table, regular row store. Once the month is closed and ended and will not be modified anymore, take it then and move it into the column store. But don't manipulate data after it's inserted in the column store. It's basically move it in and don't change it. They added all this so that you can do it if you have to, but again, it kills the performance and you have to rebuild the whole index to make a thing is, yeah. Just imagine in our case, right now, the compressed table that we have with 3 trillion rows is about 12 terabytes in size. If we would have to rebuild that index, that would take a couple of days. So that's not an option.
So what happened to the performance if the fact table need to join with the other tables?
So if the other tables have primary keys and all that, and that works just fine, like everything else, SQL Server does a scan through the partition, and then does loop joins or merge joins with the other tables. That works very, very well. Yeah, and it's the same as when you had a large fact table in a row store. SQL will scan through that table and then look up all the reference data. That works pretty good.
Cool. So this question is, I have a scenario where inserts are going on for 9 hours, which were taken a minute earlier. Uh, any guesses why it's happening like this?
So that's a good question for me. So you're inserting into a clustered column store, or
Let me see if I can unmute.
yeah,
Uh, hello, is that Raj?
yeah,
Yes, it
Um,
is.
yeah.
yeah, go ahead and
So
ask your question.
yeah, I saw the second part with so it's from a temp table into the clustered column store index. Uh, my guess is that the tab lock is going to kill it. Okay, I can hear myself now talking. That's bad.
Uh, sorry, I had to
Yeah,
unmute you, otherwise
yeah,
the
yeah, yeah,
background
it's
is
fine.
pretty bad.
Uh, so from what I'm reading here is, I mean, it's always hard to answer a very specific question, why is something performing bad? Yeah, so I'm wildly guessing here. So my guess is, why for an insert you would lock the table? I don't understand that. So wait, there's more text coming. Yeah, I will share the presentation slide. So you don't have to lock the table for an insert. Yeah. I don't know if you have to tab lock the temp table, I guess, because that hint could go wrong and actually try to tab lock the column store index instead of the temp table. That's something. But I don't know. I mean, something had to be changed. It did it. It's really hard. I'm happy if Raj is emailing me tomorrow or the day after to start a conversation with him and getting back and forth a little bit on the details. But my guess is I don't know why the tab log is there and why you would do that. Unless you want to have a minimally locked operation or so, but that will not happen on a cost of column store index. So I don't know. I haven't seen that. We insert lots of rows and they're all pretty quick because otherwise we wouldn't finish. So it depends. Maybe the rows are very small number of rows and you already have built up a lot of these external tables that get joined in. Maybe you already have deleted rows there that need cleaning up. You might have, I don't know if you have any secondary indexes on the top of the clustered column store. That might create a mess. Um, yeah, so that's my wild guessing here without knowing the specifics of what's going on here.
So you listed a number of data types uh,
Yeah.
in one of your slides. Can you go back to that one, please?
Yep.
So over here, there's no GUID.
GUID is more. GUID is 128 bits, more than 64.
That's too. Oh, okay, that's why. Okay.
Yep.
So does that mean if
You could
you have
split it in two and store it as two binary eights, and then do the stitching and querying together. Just a trick that you can use.
you mean split the GUID
You
value?
can take a 128 bit GUID and store it as 2 binary 8 and then
Okay.
stitch it together. But not sure if
Right.
this will help or not solve the problem, but it's a trick you can use. If it doesn't fit in a single column, store it in two. It's better than have a white column that prevents you from using all the optimizations. Yeah. So if it's
Gotcha.
just a value that you need to store, that could be a workaround. If you actually need to do something with it, like query it or filter on it, that could become tricky, but still doable because you can still do a compare on the binaries. And then you have to convert your where clause also into two binary compares instead of one.
Oh,
Yeah.
okay.
But yep, other than that, there's no easy way of using a GUID.
Right. Okay.
Mhm.
Any more questions from the audience? I guess that's it. So I just for you. Okay. We just saw one more. It says, sorry if this is beyond the Columnstore topic, as you were it, iterating through improvements, you you were able to test your changes with real-time data velocity in non-production environments.
We have an environment where we just process 2 or 3 servers instead of all 60 servers, and they're not the super busiest ones. And that's like our development environment where we, instead of billions of rows, have a couple of millions per day. And usually we don't process every day. We just process when we do changes and see what happens. So we have a second environment where we test that is a little bit smaller. But once we're confident that the code does the right thing, we release it to the big one. We don't have a second large environment where we basically can do a pre-production test or so. So we only thing is the nice thing about this project is if we mess up a little bit of the data, it's not the end of the world. So therefore, spending the money of having a production size test environment makes no sense. Because worst case scenario is we throw the whole day away and reprocess the whole day. We keep the raw data for a couple of days. So if we notice that something went wrong, we can redo it. So testing in real time is not, but yeah. So when we test on our small environment, it runs like production, and we do the change in the middle of it. We use a style of developing software in databases so that since we are a 24/7 shop that never basically goes down, we learned how to roll out changes while production is running. Yeah, I mean, you don't get me wrong, you cannot on a 12 terabyte size clustered column store, you cannot just easily add a column or so. That's not how it goes. But the rest of the code, when it's stored procedures or some of the auxiliary tables, that is pretty standard changes. Column store, adding, removing columns, it's possible, but it's not an easy and quick operation.
Yeah, it seems like there are quite a bit of limitations on the Columnstores, right?
Yes. So I mean, there's limitations on column store, but the results are amazing. So
Mhm.
uh, yeah, it's you need it's basically you need to follow a bunch of rules. If you don't follow the rules, you don't get the result you're looking for. Yeah. So if you want that and if you need that, that's great. If you just want doing things the way you did it for the last 20 years, it might not work. Yeah? So for me, column store solved the problem after we learned how to use it correctly. when you don't use it correctly, it will still do something. It's just not things. Yeah. And the problem with adding, removing columns, any kind of 12 terabyte big table, when you try to add columns, you will have surprises, yeah, because it's not that easy, yeah. Because when you change the structure of a table, you never know if it's a physical or a logical operation, yeah. So when you add a nullable column on a regular table, it's usually a metadata operation, except if your null bitmap runs out of bits, then it becomes a physical operation and they have to insert one new byte in every row. So you add 3 or 4 times a column with no problem, and then you add one more, and suddenly the whole operation takes 3 days. So same thing here. Yeah, you have to be careful. You have to test it, but it's possible. But needs same on the thing is, yeah. Working with multiple terabyte large tables is a difference. Yeah, if your column store is, I don't know, 1 billion rows in total, it's much easier to handle it because you create the new structure, you copy the whole thing over, and will run for about, I don't know, overnight or so, and next day you have the new structure. Yeah, so it's a tool. Used correctly, it's great. Not used correctly, you will
So
be
how,
disappointed.
okay,
Yeah,
how would you find out, if the data load, because earlier you mentioned like, if the data wasn't loaded correctly, then it's
yeah.
not a big deal. But how would you find out, whether or not the data are loaded correctly or
So
not?
there's metadata inside. So there's metadata for the column stores in the system tables, where you can see which types of row groups they created, if it's in a B tree or is it actually a compressed and closed row. Yeah, I refer to Bob Ward's presentation from last pass, which is still downloadable from the Summit website, and it explains how to go through all the metadata and find that out. It's a simple select from a couple of system tables, and it tells you each and every row group how it's if it's perfect or less than perfect.
Okay. So it's Bob's presentation was at Summit 2018,
Last year, so last year,
last year,
yeah, the
2018.
last one, yeah, 2018,
Okay. Okay,
yeah,
I'll try to find it and upload to
mhm.
our site.
Yeah, it's also on his Bob Ward's standard uh, um, place where he uploads all his presentations. It's also there.
Oh,
So
his
yeah, and
blog?
I'll just send you a copy. Uh,
Oh, wonderful.
yeah,
Cool. Thank you so much.
okay. So
I
good,
guess that's all the questions we have.
good. Thank you very much for listening. I hope it was helpful. And let me know. Thank you.
Yeah. Thank you. Thank you everybody for attending. And this session is recorded. I will upload the recording to Past TV tomorrow. And once I get the slides from Tom, I'll upload those to our website as well. Thank you so much, Tom, for the
Yeah.
great presentation
Yeah.
tonight.
Okay. Yeah. I'll send the slides in the next 5 minutes. Okay.
Okay,
Cool.
cool.
Thank you.
Thank you.
Bye.
Thank you everybody for attending, and hopefully to see you all on our next session on 24th, I think, of this month. Thank you everybody. Bye.